everyone. Because the school is closed due to coronavirus disease, we are starting online program in which we will be giving you some videos so that you can understand the topic and do the homework whatever we are giving. In chemistry in standard 8, the first chapter is matter. Now what is matter? In terms of science, anything which has mass and occupies some space and its presence can be felt are called matters. For example, if we take some amount of water, it will have definitely some mass, maybe 100 gram, 200 gram, and when you take it in a glass, it will occupy the space, the volume inside the glass, so it occupies a space. So water is matter. So matter is defined as anything which has some mass and occupies volume. So in this whole universe, matter can exist in three states: solid state, liquid state, and gaseous state. There are other forms like plasma state or Bose-Einstein state. These two states are beyond the scope of standard 8. So we will be discussing mainly the three states of matter, that is solid state, liquid state, and gaseous state. So matter exists in three states. Solid, for example, iron, ice, etc. Then liquid, like water, milk, oil, etc. And then gaseous state. For example, oxygen, carbon dioxide, water vapor. Now the question is, why some substances are in solid state while some are in liquid state and others are in gaseous state? So to explain this, the three states of matter, we'll have to understand a theory, what is called kinetic theory of matter. Kinetic theory of matter, which says that substances are, or any matter, any substance is made up of tiny particles called atoms, molecules, or ions. So this is first point of the kinetic theory of matter. The substances are made up of either atoms or molecules or ions. Second, now why we call it as kinetic theory, that particles present in substance are in motion. Kinetic means moving, particles are moving. So second point is that these particles present in a matter, present in a substance, are moving some amount of kinetic energy. So kinetic energy. Third, during kinetic motion of molecules, there will be some distance, some gap between the two molecules, what is called intermolecular space. Okay, suppose one molecule is here, another molecule is here, so this will be called intermolecular space. And the last point is, there is some kind of force of attraction between molecules. So suppose that is called intermolecular force. Okay, suppose if one molecule is here, another molecule is here, so there is some force of attraction between these two molecules. So based on these 4 points, we will be explaining that why some substances are in solid state, some are in gas state, some are in liquid state. Okay, so once more, according to kinetic theory of matter, we have tiny particles present in matter called atoms, molecules or ions, and these molecules and ions are having some amount of kinetic energy, means they are moving, and there is some intermolecular space, that is distance between the two molecules or gap between the two molecules, and these molecules are attracted by some force of attraction, what is called intermolecular force. Now based on mainly these two factors, that is number 3 and 4, we can explain why a substance will be in solid state or in gas state or in liquid state. In solid state, molecules are very close together, that is particles are well packed, almost touching one another. And so what happens in solid state, the intermolecular space, the gap, the distance between the two molecules will be minimum, they are almost touching one another. And so what will happen, if the molecules are very close to one another, the force of attraction will be strong. So in solid state, the intermolecular space is minimum and force of attraction is maximum. In liquid state, what happens, these molecules are slightly far apart. Say one molecule is here, another is here, like this. So what you find here is intermolecular space has increased, and so the force of attraction will decrease. But although the force of attraction has decreased, but it has not decreased large enough so that it will escape from the liquid. The molecules are moving, but if you take in a container, the molecules are moving, but it will remain inside the bulk, it will remain inside the liquid. In gaseous state, what happens, intermolecular force is negligible, almost nil, you can say minimum, and the space, intermolecular space, is maximum. So due to this, what will happen, in gaseous state, kinetic energy is maximum, the molecules are moving randomly in different directions. Randomly means, there is no fixed direction, in all different directions they are moving, and because of that, what will happen, in gaseous substance you cannot store in a in an open container. We can store liquid like water in a glass, but we can't store water vapor in a glass because the molecules are moving so randomly with very high kinetic energy that it will escape from the glass. Okay, so in terms of kinetic energy is minimum in the case of solid, kinetic energy is moderate, kinetic energy is maximum. Intermolecular force is maximum in solid, then here again moderate, but intermolecular force of attraction is almost negligible. Space minimum, moderate, maximum. Okay, so based on this, what are the characteristics of these three states of matter? Okay, characteristics means what will its shape, what will its volume, how many surface area it will have, whether we can store in an open container or not. So characteristics. Of the three states of matter. Suppose we take here solid, here we take liquid, and here we take gases. Okay, so whether it is solid, liquid or gas, if you take any amount of any substance, whether it is solid, liquid or gas, it will have definitely some amount of mass. So if we consider mass, for solid the mass is fixed. Suppose if you have taken 200 gram of ice, it will always remain 200 gram. If we take 200 gram of water, then also its mass is fixed, 200 gram. If we convert this 200 gram of water into water vapor, then also its mass is fixed. So in all the three states of matter, mass remains fixed. Now another, if we take volume. Volume of solid is fixed. Volume of liquid is also fixed. But volume of gas is not fixed. It is indefinite. What does it mean? See, if we take say 100, suppose if you take a small cube of ice and say its volume is 1 centimeter cube, it will remain 1 centimeter cube always. Now if you take 1 liter of water, whether you take in a glass or in bucket or in mug, it will remain 1 liter only. But the volume of gas is not definite. It is not fixed. We can store 1 gram of hydrogen in small sachet in a small bottle. But if you can transfer it in a big gas jar of which is completely sealed. So the volume, suppose if we have transferred that hydrogen gas from one small sachet to another big container, that whatever be the volume of that container, that will become the volume of the gas. So in fact, the volume of gas is the volume of the container in which it is stored. Okay, so volume is not definite in the case of gas. Another property, if we take shape, solid, the shape of the solid is fixed. It has definite shape. Definite shape. Whatever be the shape of this pen, it has got definite shape. It will remain as it is. But suppose if we take 1 liter of water in a bottle, it takes the shape of the bottle. if you transfer that water in another container, suppose in a jar or in a mug, it will take the shape of that container. So liquid, the shape of the liquid is actually the container in which the liquid is stored. Okay, so for liquid, the shape is not fixed, indefinite shape. And for gases also, the shape is indefinite. For example, suppose if we have oxygen cylinder, the shape of that oxygen gas is cylindrical, like the shape of that cylinder. From that cylinder, if we use that gas to inflate a balloon, the shape of the gas now is the shape of the balloon. So for gases, volume is not fixed, even shape is not fixed. So these are the main physical characteristics of the three states of matter. Now sometime we try to analyze whether the light we receive from the sun or from the bulbs or any, say, the tube, etc., whether it is a matter or not. Similarly, when you hear some sound, it is a matter or not. Now we can feel the presence of light. We hear the light, sound. If somebody is speaking to you, you can listen it, sound is produced. Now the question is whether the sound is also matter or not, because we can feel it. We can feel the presence of light. Okay, so although we can feel the presence of light or sound, but they are not matter. Why? Because light has no mass, it has no volume, it does not occupy any space. Similarly, sound has no mass, it does not occupy space. So light and sound are not matter. Then what are these? These are simply different form of energy, just like electricity also. Okay, so light, sound and electricity are not matter. Now one thing more we have to do in this chapter. What is law of conservation of mass? You know meaning of conservation means it is neither created nor destroyed, it remains constant. That's meaning of conservation. So according to this law, during a chemical reaction, the total mass remains constant, neither mass will increase nor mass will decrease. Only thing will happen, what? You may get a new substance formed, but the total mass will remain constant. So according to law of conservation of mass, during a chemical reaction, total mass of the reactant, you know meaning of reactant, reactants. Reactants are substances which undergo reactions. And after reaction, some products are formed. So total mass of the reactant will remain equal to the total mass of the product. So neither mass is created nor mass is lost. This is meaning of law of conservation of mass. So we take one example. For example, you know, all of you know that hydrogen reacts with oxygen to form what? Okay, see, with this example we have to prove the law of conservation of mass. If we burn 2 grams of hydrogen, with 16 gram of oxygen, then you will get 18 gram of water. So you can see here the total mass before reaction is 18 gram and after reaction is also 18 gram. So mass remains conserved. I give one more example. When we burn carbon, say coal, suppose if you take 12 gram of carbon, coal, pure coal, and we burn in 32 gram of oxygen. Okay, now all of you know when carbon is burned in oxygen, what will the product form? The product form will be carbon dioxide. Now if you burn 12 gram of carbon, coal, pure coal in 32 gram of oxygen, and it will form carbon dioxide. If we collect that carbon dioxide and weigh it, you will find it will be 44 gram. So again you see here the 12 gram plus 32 gram, that is 44 gram is the mass of the reactant, and mass of the product is also 44 gram. So from these two examples we have proved the law of conservation of mass. In this chapter this much only you have to do. Now what you will do, I will be uploading some questions and answers of different questions. You will copy down. At the same time I will be also uploading the exercise questions. You please solve that, and in case if you have any problem you can WhatsApp me or you can mail me. Thank you very much. Okay, next day we will be discussing the chapter 2, but I am giving you 2-3 days time. By the time you complete this chapter, please. Thank you very much.